Hi guys, so in this video we're going to cover the A1.1 water content for HL. This is HL only, so yeah. As we know, 70% of the Earth's surface is covered in water in a liquid format. But where does this water come from exactly? Right now, scientists believe that water has come from asteroids, or more specifically, asteroid bombardment. Asteroid bombardment, where asteroids like crash into each other and that water would have landed on Earth. And here's why. So they have large amounts of water, or had of water, and we're gonna get into this later. The same ratio of of heavy hydrogen to ordinary hydrogen, and the same ratio of have the same ratio of these hydrogens as the water on Earth does as well. We're going to get into this in a second. However, one thing that might disprove this, but not entirely, it's that now asteroids collide much less. Like you don't see asteroids colliding every day, in space or whatnot. And they also have a lot less water due to heat and evaporation from the sun, obviously. So yeah, now we're back to this heavy normal hydrogen stuff. Water at the moment exists in two forms, and that is because the difference, so for hydrogen, it's because of a difference in the number of neutrons. In a normal hydrogen atom, there's only one proton and then one electron. Okay? But in heavy hydrogen, um, the hydrogen atom is one neutron. So one proton, and they also have one neutron and one electron, obviously. And so that changes the mass, hence why we call it heavy water. But this is also called, let me just write it down. It's also called deuterium, like that. So all water consists of a mix of both heavy and normal hydrogen, but on Earth, the ratio of heavy to ordinary is the same on asteroids, on the asteroid belt, and here on Earth. So that's why we think that the water we have on Earth has come from asteroids. Also, following on, I'm sure we all know how water is one of the key things that makes Earth the only habitable planet. And that's because we are in something called a Goldilocks zone. Yeah. Goldilocks zone. And this is to do largely with the retainment of water on Earth. So this concerns the distance of a planet from the sun, or from the star, rather, of the thing. And it also depends on the size of a planet. Now, the distance of this distance between a planet and the sun, or the solar systems, or the star within that certain system, that allows for water to be below vaporization temperature. So Earth is at the distance between the sun that it's below vaporization temperature. And so water therefore remains largely as a liquid unless there's interventions such as heating, freezing. And also the size. Earth has a large size. So this means there's a greater gravitational pull, allowing us to retain the water, actually keep it tight to our surface. as oceans or whatnot. Like if you compare Saturn, for example, it might have a large size, it might be able to retain water if it had water, but it's so far away that it's not at a high enough temperature to keep water as ice. I mean, as liquid, it'll be ice instead because it's too cold. It's so far away from the sun. If we take a closer planet like Mercury, it's first of all it's very small, so they can't have that gravitational pull. But it's so close to the sun that any water would evaporate immediately. So therefore, it's not in the Goldilocks zone. Now, this Goldilocks zone will vary from different like solar system to solar system. Um, but yeah, the sun for hours with the sun, currently Earth is in this Goldilocks zone.